In our last video, we determined that we needed 4 160-watt solar panels to support our AC and DC loads. Now that we have determined the size of the solar array we need, the next step is to select the type of charge controller we need. There are two types of charge controllers: pulse width modulation, or PWM, and maximum power point tracking, or MPPT. A PWM charge controller is suitable for small to medium solar systems, where solar is used strictly as a battery maintainer. While cost-effective, it is not very energy efficient. However, it could be a better choice in a smaller solar system, where the higher cost of an MPPT charge controller may not justify the difference in power output. It is generally used for 12-volt battery systems. You would only want to connect your solar panels in parallel using a PWM charge controller, but more on that in our next video. MPPT charge controllers are ideal for medium to large solar systems and for 12-volt, 24-volt, or 48-volt battery systems. MPPT charge controllers allow for higher solar array voltages and offer greater flexibility in the size and configuration of your solar array. MPPT charge controllers are more expensive, but are up to 30% more energy efficient than their PWM counterparts. The reason an MPPT is more efficient than a PWM is due to the MPPT's tracking ability to find the maximum power point for a solar array, where the simplicity of the PWM design cannot do so. The MPPT has a DC-DC converter, which downconverts the solar panel voltage to the battery voltage, but at the same time, upconverts the battery charging current in order to maximize energy transfer. With a PWM, the solar panel voltage will also lower to the battery voltage, but the battery charging current does not change, resulting in a less efficient energy transfer. Let's take a look at our example. Note, we are using a 12-volt battery bank. Our 160-watt panel has a voltage of 19.2 volts and current of 8.34 amps. Formula number 1. Using a PWM charge controller connected to a 160-watt panel. With the PWM, the panel voltage lowers from 19.2 volts to 12 volts, and the charging current stays the same at 8.34 amps. 12 volts multiplied by 8.34 amps equals 100 watts power output. Formula number 2. Using an MPPT charge controller connected to a 160-watt panel. With an MPPT, the panel voltage also lowers from 19.2 volts to 12 volts, but the charging current is upconverted by the same ratio that the voltage was downconverted by. 19.2 volts divided by 12 volts equals 1.6. Charging current increases by a ratio of 1.6, so 8.34 amps multiplied by 1.6 equals 13.34 amps. 12 volts multiplied by 13.34 amps equals 160 watts power output. Our 160-watt panel can produce maximum power output of 100 watts using a PWM versus 160 watts using an MPPT. This is a major difference. In our example, we have a 640-watt solar array comprised of 4 160-watt panels. It would make sense to use an MPPT charge controller. We will learn about wiring of panels using an MPPT charge controller in our next video.